Thank you all for being here today. We're super excited to close out these presentations. We are the Smart Bike Rack Group. My name is Megan Ockbach, and I was the electrical engineer on the project.
I'm Maya Wald, and I'm a computer science major.
I'm Matthew Hassan. I'm also a computer science major.
I'm Colby Raish, and I'm studying construction engineering.
So this is a tale as old as time. You live in an apartment, you've got a bike, and you don't exactly know what to do with it. You know, you can leave it outside, it's raining on, it's getting rusty. So you're stuck hauling it up the stairs. And it's fun for nobody. Those hallways are tight. And so we wanted to come up with a better solution. And so we designed Bike Nest. And Bike Nest is a wall-mounted bike racking system that is intended to be used in a high-end apartment community as an amenity for their residents. And so Bike Nest is a secure solution. We've added to the design an electromechanical locking mechanism.
It is also convenient because it can be controlled from a mobile web page.
And it's versatile that accommodates a wide variety of bike types. So I was responsible for the structure on this project. This was just an initial sketch that I had. Basically, my idea was I wanted it to go in kind of a cubby cutoff area. You could have it, in a building in an area, and you could have a bunch of them on the wall. And then you could loop this cable through all of your stuff and your bike. And another big thing is you can, wrap it through the back wheel, the front wheel, the frame, get all those high-end parts that are. So next slide. So as far as constructing this goes, from the CAD model, I pulled a one-to-one template of the shape. So this is a pretty complex shape to cut out of wood anyways. And basically I printed out a one-to-one template, glued it to plywood, one of these, and then used that as a template to cut out the rest of them. These were all glued together, and then same thing with the plexiglass. I used this as a template. And then I used a router and a drill press to machine the countersunk holes for the screws, and then these slots for the cable too. And then, so that's a picture of everything and sanded flush. And then for the drill press, I had a pretty small drill press, so I had to get a little creative. I turned the base plate on the drill press around as far as it would go. And then I had a whole clamping set up to get this bottom pin in that permanently holds that cable in. So that's 3/8 aluminum, had to get a 3/8 hole out a little bit of there. And then for this hook, this was a addition I made after while I was building it. I was thinking it'd be nice to have a spot to store the cable when it's not in use. So I bent a hook and then drilled a hole for it up here as well.
All right, so I was responsible for the controls on our project in the form of three main things. Number one, the interface on a user's phone. The ESP32, which is going to take those inputs and drive our mechanism. And this locking mechanism, I had the vision of using a linear actuator. And so I found this company online called Actuonics Motion Devices, who specializes in making micro actuators. And so I reached out to the company. I had noticed on their website that they had a bunch of education initiatives. They had engineering scholarships. They sponsored FIRST robotics teams. And so I thought, I bet they would want to sponsor a senior design project. So I reached out to the guy and he got us hooked up with parts. One of them was their P8 linear actuator. It has a 25mm stroke length, which is not very long, but that's exactly what we needed. And then it also had a 50-to-1 gear ratio. Because we're not pushing and pulling a load with the actuator, we didn't have to get crazy with that either, which helped keep that cost low that they were giving us. They also set us up with their linear actuator. This control board works with their Dash P models, and it offers many different interfaces on how to control the stroke length of the actuator. The method we went with is PWM, and so it took the duty cycle of a 1 kilohertz square wave, and that encodes the length that the actuator is actually extended. And so to set that up on the ESP32, it's going to start up and it's going to initialize that PWM. After that, it's going to set up our Wi-Fi and start that web server. This was a really big challenge for me. I had never done anything with Internet of Things, and so I was really starting from square one. So getting that live was a big hurdle to get over. It's going to accept a new client connection, and then it's going to read the incoming HTTP GET request from that client. And that GET request is going to be one of two things. It's going to be lock or it's going to be unlock. And then based on which request it is, if it's unlock, it's going to PWM a 1% duty cycle. And if it's lock, it's going to output the 100% duty cycle. Those values can be adjusted based on the actuator we had. We were able to just use full extend and retract. But if you had one that was longer than it needed to be, you could set those limits if you only needed it to go from like 25 to 75%. It's going to update that actuator state on the web interface, which you'll see in the demo. And then it's going to return to wait for the next from the client. So I do have a video here. Note it says the bike rack is locked. That state will update, and then the state on the unlock button will also update. And so all this HTML is it takes that request from the button and triggers a GPIO input-output with the PWM on the ESP32. All able to be done just on my phone running a hotspot, and then you just connect to the IP address.
So then we had the back end. Back end is mainly for data transfer, data reading, just to keep everything running smoothly. To store the data, we used a MySQL database. It's easy to use, it's fast, data quickly, which was a big thing. The two main database systems I was comparing were either MySQL or Postgres, and this one seemed to be the better one for our uses. The backend API was written in Java Spring Boot, which is a framework written in Java. I picked it for two main reasons. One is my familiarity with Java. That's the main programming language that I've used. And the second is it's highly compatible with the Angular front end, which is what my use for the web page. So the API writes and reads data to a SQL database, and it will return the data to the front end using HTTP requests. So when you start the web page, it establishes the connection with the database. It accepts HTTP calls. If it's a post request, then it checks if it's valid. If not, it sends back a 400 bad request error. Otherwise, it adds it to the database and sends back a created status code. If it's get put, checks if the data already exists in the database. If it's not, it returns a 404 not found error. If it does, if it's put request, checks if it's a valid request again. If it is, it'll actually update that data within the database. Delete request, it will delete the specified data, send back a 200 OK status code. If it's a get request, it will return the requested data back to the client with a 200 OK code.
For the front end of the web page, like Matt said, we decided to go with Angular. Angular is a platform and framework for building single-page client applications using HTML and TypeScript. We chose it based on its compatibility with the Spring Boot backend. Its component-based simple development is really easy to use. And then it has integrated form creation and validation, which I used for the register and sign-in screens, and then just prior experience with the platform as well. We were able to deploy the web page on Azure, which is a Microsoft cloud computing platform. Our design goals were for the web page to be simple, intuitive, reliable, and accessible, and also for it to be optimized for mobile browser use, because that is how most of our users would be accessing the web page. Here is a demo of the web page, and on the right side, you'll be able to see the API calls being made to backend. So when a user comes to the web page, it's the screen they would see, and then they would go to register their bike and just enter their name, the apartment, and then make a username and a password, just like creating any account. And then when they press register, it'll create an account in the database. And then they can see that their bike is unlocked and how many racks are open at their apartment. Select a rack number and put in their password. Once they press the lock button, that'll start the process in the back end, and that'll be initialized in the database as well. Then they can sign out and go on their bike ride. And then when they come back, they'll sign back in with the username and password they created before. They'll see that their bike is still locked. Then they can go to unlock it just by putting in their password.
So here's the cost analysis we did of our prototype. And so the two biggest cost hits on the control side were the actuator and the linear control board. And so that was about $115 of cost just for those two components. The ESP32 was only about $16. And then the rest of the parts we used was less than $15, which meant that if someone was to go out and build a prototype with what I did, it would cost them about $142.75.
Yeah, so as far as the physical structure for the project, so there's some drywall costs and then the stud frame behind it. This is just a normal stud frame wall, just 3 1/8 standard nails. There is some extra blocking behind the wall that's required that should be done before construction. So we use some GRK RSS 5/16 by 5 1/8. So they're just standard, heavy duty bolts. So those screw the bike rack to the wall, and then the blocking behind the wall is also fastened using those larger line bolts. We had some screws for the plexiglass. This took about a half sheet of plywood. It's a somewhat inefficient shape to cut out of plywood. Even if you were, optimizing and using a CNC, which if you're manufacturing this on a large scale, you would. You might want to make some breaks in this and, put it together in a little bit of a different way to get a better yield out of each sheet of plywood. There's some glue in there and some aluminum. And then as far as the grade of plywood, that's pretty important. You want something that doesn't have a lot of voids and is pleasant to look at since there's so much exposed edges here. So there's some voids in B2, so the grade we ended up going with. There's A, B, and C grades. We just kind of picked something in the middle. A full sheet is about $90, so we had about $45 associated with half a sheet.
So between the two of our components, it was $261 if you were to go out and recreate this. We did not have any cost for our prototype from the front end and the back end because we were not hosting on a server. If this was something that was going to go into production and actually be marketed to users, you would incur a cost from that. So grand total between controls and structure was $261.51. With the sponsorship, it was only just under $150 out of pocket for our prototype. In terms of future work, one thing we've identified is integrating the controls with the web. You guys saw my web application was very different than the one that Maya created. But to do that would require a second backend to be developed. In terms of manufacturing strategies, Colby kind of touched on that. If you were to put this on a CNC to mass manufacture it, you would have to reconfigure the design. And then also upgrading those components for higher security. Thicker acrylic could be used on the side. A stronger actuator could also be used, maybe one made out of steel. So there's a lot of opportunities for that to be upgraded as well. That's not in our prototype. So kind of to finish it off, we'd like to give some special thanks to Professor Volkman, who I don't think he knows it, but helped me out quite a bit on the internet stuff. And he was also for Matt and Maya on their side of things. Mike Grieg is who I worked with at Actuonics. He was incredibly generous working with us. Ransom Schmidt is someone from work who helped us with our rapid prototyping and 3D printing. And then Noah Groman was our additional support and helped us move the heavy structure a lot. So thanks to all of them.
But can you explain how do you wrap or how it's supposed to actually secure the bike in the
Yes.
whatever
So
belongings?
a big thing for me is if you have a nice bike, you don't want anything really touching the frame. So especially like carbon frames, when you scratch them or dent, it reduces the strength a lot and they can break. And it doesn't seem like something like this would cause those kinds of issues, but it does in real life. So you take this cable. So this is permanently attached with an aluminum 3/8 rod. So that part never comes out. You'd loop this through your bike and then it would go into this side and then lock. The actuator would lock it. So then, it would be secured and it wouldn't come out. As far as how it goes up against the wall, if you have a kickstand for your bike, you'd use the kickstand and just kind of set your bike here, kickstand, lock it, and you're good to go. A lot of mountain bikes or high-end road bikes don't have that. So what you would do is put a handle at this side and then lean the back tire against the wall. And then, it's a very natural way for you to sit. And it's not going to fall over or anything like that. in something like this in an apartment building where there's not a lot of wind or anything like that. So
You consider it being like vertically, so it doesn't take up so much space.
Yep, we actually did look into some design ideas for that. Where we went away from that idea is just our users, you know, like a lot of families have bikes, they've got like little kids and then also older people. You know, this could be used, older people like to be active on bikes specifically because it's a lower impact activity. And so to be asking an older person to lift their bike up was something we wanted to get away from.
another thing with that too is when you're looking at going with pretty much any type of bike, if you have some or recumbent or any other specialized sort of bike other than like a standard diamond frame, it's very difficult to hoist something up like that and have it be intuitive for a wide variety of bikes. So that's kind of what led us to just go as simple as possible with this. Yeah.